Okay, so let's get started. We're going to be taking a look at how to spot and correct bad injector data when we're calibrating and tuning in our model fuel equation mode. Now, up to this point in the training course, we've went over what the model mode represents pretty extensively. We've went over the airflow model, we've went over the fueling model, so we understand that we have our basic underlying equation: fuel mass is equal to air mass divided by target air fuel. The air mass is represented based on knowing our volumetric efficiency that we express here in the table, which is the percentage of cylinder filling. We also have other variables to account for the estimated air mass. It's going to be number of cylinders, the engine displacement. We also have our map pressure reading that plays a role in our estimated air mass, along with our charge temperature, which is the air that's entering the intake port that's actually going right into the combustion chamber. So we have to go and model all of that. And what we get is an estimated air mass. We know we divide it by our target air fuel. That's going to be a combination of our target lambda table multiplied by our fuel stoich value that we place here. This is based on the fuel type that we're actually calibrating and tuning with. So for example, if I set it at 14.7, that means I have pure petrol fuel in my fuel system. So if we understand the air mass, we can call out and tell the link what we want to run for a target air fuel. We can calculate a fuel mass. Now the fuel mass gets converted into an injector pulse width, knowing a couple different variables. We have to enter in the injector size that we're dealing with at whatever the rated pressure is going to be. Link will take a look at our fuel system type, whether it's map referenced, returnless, or running a fuel pressure sensor, and it can calculate then what the conversion of fuel mass into a base injector pulse width is going to be. That's going to be our injector effective pulse width. Then we add our injector latency or dead time to the base pulse width coming from our dead time table. This can either be in a 2-dimensional or 3-dimensional format. We specify that right here. That's going to be our dead time. What we're left with is the injection actual pulse width. This is the total pulse width that we're sending to the fuel injector for it to pulse, to open and close, to spray the fuel into our engine. Now, if everything is correct, meaning we've expressed the proper injector flow, we've expressed the proper latency or dead time response for the injector, we've also went in, entered our basic variables correct in here, and we have our volumetric efficiency cylinder filling correct in our table. We'll find the equation should be balanced, meaning if we're requesting a certain target lambda, target air fuel, we'll be hitting that exact target measured air fuel looking at a wideband sensor. What's going to happen when we're richer or leaner than the target? Well, naturally, we're going to want to go into our table here, into our volumetric efficiency table, and in a perfect world, this is going to be what we actually calibrate and tune. So we'll have to raise the numbers up or lower the numbers down to tell the link that we're moving more or less air into the engine. Raising the values up, if we're lean, that'll tell the link that we have more air coming into the engine, and therefore we need more fuel mass. If we lower the values down, let's say we're too rich, we want to lower the values down, that'll tell the link that we're moving less airflow into the engine, and therefore we need less fuel mass. That'll lower the fueling to the engine and lean us out a little bit and hopefully correct the imbalance that we're seeing. We're going to find, in a lot of cases, when we're running aftermarket injectors, when we specify the injector data coming from the injector manufacturer, even if it's a quality company like Injector Dynamics or FIC, when we enter in the flow rate and we enter in the injector dead time, a lot of times we're going to find we'll have a discrepancy in our fueling even with good data. And that's going to lead us to a lot of times absorbing bad flow rate or bad dead time data into our main volumetric efficiency table here. We want to express the estimated airflow correctly to the link. We don't want to bake in bad injector data. So this tutorial, what I'm going to do is show you a couple examples of bad injector data for both flow rate and latency. And we're also going to learn how we can look at some log data at idle and even at full throttle and use an Excel spreadsheet calculator to do a logical check on the values coming from our table here. So let's first take a look at using the calculator and look at some log data, and then we're going to go through and look at some bad examples so we know what to look for and what to spot in terms of trends in our volumetric efficiency table, because it's pretty clear when you see the values that are incorrect in the table, you'll know exactly what to look for, and you'll know to avoid doing that when you're calibrating and tuning your engine. Okay, so the first thing that I'm going to do here is jump in. I'm going to go to logging and open log file. And in our course folder, if we'll go to the desktop here, the G5 course packet, we're gonna go to our sample log file folder. Double click in here. Now I have two different air mass check logs. We have an idle air mass check and an idle VE log. These are both something we can reference. I also have here a VE injector differential example. We looked at this example in another training module when we were talking about the modeled fuel mode. We're gonna still go ahead and take a look at that here again, just so we can use these and learn what we need to spot in the log file or in the live data, and being able to plug the numbers into our Excel spreadsheet calculator so we can get an idea if our values are correct or not. All right, let's go here to our idle air mass check. Let's just go ahead and open this particular one up here. Now this data log is from a vehicle that I was calibrating and tuning, and I just captured a log as a driving cycle. You can see here it was about 10 minutes long. You see our timestamp down here at 10 minutes. Now obviously taking a look at this looks like a bunch of squiggly lines on our graph down here. What we're looking for, if we go to the upper left-hand corner, we see engine speed. What I'm interested at this point is going through here and highlighting and looking at my engine speed at idle conditions. So even right here, we'd have idle. So the idle is about 1,050 RPM. The next thing I'm going to be taking a look at is going to be my air per cylinder estimated value. We can find that right here in my parameters list. So wherever I put my cursor at, that's going to be showing me what that value is going to be associated to that specific spot where my cursor is in my time plot window. Now, if we're connected live to the vehicle, so if you don't have a logged information and you just want to be able to take a look at this live, you'll be looking at this runtime value screen right here, and specifically at your air per cylinder estimated at idle conditions. So that's the key here. We're looking at it at idle conditions right now. Okay, so what we'll find here is we have our engine speed, 1,055, and then we have our air per cylinder estimated value at approximately 0.12, let's say round that up to 0.129 grams per cylinder. What we're going to do is take this information and we're going to be putting it into the Excel spreadsheet calculator to do a logic check to see if the volumetric efficiency values in this model fuel mode as I'm calibrating and tuning make sense or not. Are they accurate? Are they too high, meaning the volumetric efficiency? We can see our cursor. If we click H right here on the table.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.